All right, good morning again. This is our last class for the network cabling class, ELEC 1013, 2025, Fanshawe College, London, Ontario. All right, this is the second part of the, tools and equipment that is involved. So this group right now that's online, you're going to get the second part first. And then you're going to get the first part in person next time we meet each other this week. This way, all the classes, part 1 and part 2 of every week is posted on YouTube, so you can use that as a reference. Okay. All right, that's where we're going to start. Pick up on this thing here. Site work cable installations begins with establishing the pathways. Now, what do you mean? What do I mean by establishing the pathways? What you do is try to establish as many straight runs as possible. So if you have a cable bundle, let me just get my board here to explain things a little bit. I can't have that now. That's the beauty of online teaching. Just firing up my board here. Bear with me. All right, so let's say we have a building here, or a floor, and there will be some rooms here, there will be another room here, there will be another room here. So let's say there's some kind of office space, and over here we have the, let's say, somewhere there will be the LAN room, okay? And this here is right here, this is a ceiling space. So of course, if we have to get 2 wires to each office, so of course we're going to have some sort of a main bundle running through here of the wires, and then from here somewhere you're going to fan things out into each office. Let's say if we have so. The straight, the main bundles, you gotta establish as many straight bundles as possible, so the wire pulling can be done efficiently. Now, this is a simplified version of of anything that you're going to encounter as far as cable installation. Sometimes things are getting more complex. Sometimes the LAN room is going to be here, and you're going to have to run things like that. Now, there's going to be sometimes some equipment in the ceiling, such as HVAC equipment, climate control, whatnot, some other things, heat pumps, and so sometimes the ceiling is a nice and comfortable space to work with, and sometimes things are quite heavily packed. So what do? Is we establish some straight runs. How do we establish a straight run? There's going to be in the ceiling going to be some sort of construction, like maybe red iron. And what's a red iron? Red iron is the okay. Red iron. Let's say here is the room. And this is the floor. Right now, here's the floor. Let me just. There you go. Okay. That's you, and that's the floor. Now, there's going to be a ceiling space with ceiling tiles, and here's going to be the plenum, which is the space between the ceiling tiles and the true ceiling. And quite often, you're going to see some kind of like a metal construction here, steel construction. And sometimes supported with straight bars and so on. And quite often that thing is painted red, so popularly it's called red iron. Okay? So what you do is you take the twine, the string that we used to bundle those wires when we were doing the nose prep lab, and try to establish a straight run with the string. So you're going to get maybe a ladder here and step on the ladder. That would be you looking that way. And try to find some sort of a straight line, and maybe you can just get the ladder here, 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 move it around, and establish a straight run with the string that you can just basically put some tension on the string, and you can have, quite often you can find it. So you tie the string on one side, tie the string to the other side, and then you're going to have the string coming down to the floor. Here you can tie the wires to the string, do that nose prep thing, pull that on the other side. So it takes two people, one person feeding the wires into the ceiling space and the other person pulling the string with the wires later. With one person, quite often it's difficult to do because any obstacle, any right angle, anything that the wire is going to be rubbing onto, they're going to produce friction, and they're going to basically give you the opposition to the wire pulling. So, but the other thing is you have to remember that the wires, data wires, have to be treated with extra care. So you have very little room to yank it stronger or something like that, because you can just damage the wires. And if you're not careful, you can also damage some stuff in the ceiling. So so you gotta be So that's what I meant by main runs should be kept in bundles, suspended independently of any ceiling structures. All right. Why do we have that? Just make sure that you don't miss any wording that I give you here. Should be suspended. So the wires should be suspended independently of the ceiling structures, of any ceiling structures. What do I mean by that again? Well, those ceiling tiles, they're sitting on the frame, like an aluminum frame, and that frame is supported from the true ceiling. So quite often it's just they're driven into the concrete there. They're suspended by those rods, iron rods. Before, many years ago, what people would do is just have the wires run right on top of the ceiling tiles, and then just bring them up and tie them to the rods that are holding the ceiling tiles frame. That is a big no-no. We are not supposed to do that. We cannot do that. Any wiring should be tied to the red iron if you can. And if you can't, there are those J-hooks that we're going to talk about in the next couple of slides. J-hooks that are suspended on, let's say, threaded rods, or use cable trays or any kind of other raceway, as long as those wires are not tied to any of the ceiling structures, especially to the rods that are hanging from the ceiling and are supporting the ceiling tiles frame. The reason for that is, the reason for that is that, God forbid there is a fire, but fire regulations are in case of fire. So in case of fire, there would be some firemen coming in there with those, I don't know what they're called. They're kind of like hooks on the stick, all right? And they're going to pull that ceiling tile structure down to kind of make sense out of the, try to put out the fire and whatnot. So if there are things tied to the ceiling structure, it is going to pose some kind of a hazard for the fire people there, and that's going to basically jeopardize their safety. So for that reason, that's the main reason why the wires should be independently suspended, independently of any of the ceiling structure. And what they mean by that is mostly it's the ceiling tiles and the structure that is holding the ceiling tiles. All right. As much as possible, establish straight runs so pulling multiple cables can be done efficiently, which is what I just talked about. If you have, let's say, a bunch of offices on the other side of the room, then and you have, let's say you got 12 boxes, 12 wire boxes. So you can put as much 12 wires at a time. So establish the straight run and use that straight run to go as far as possible before the wires start fanning out into the individual locations. This way you can do the wires nicely and efficiently, safely, and you're not going to run the wires all over the ceiling space. So the professionalism of the installation would be also kept. Plus, if you need to get at any of the wires, you know where they are. Now, J-hooks mounted on the walls or suspended from the ceiling on threaded rods. What am I saying here? J-hooks mounted on the walls or suspended from the ceiling on threaded rods. I'll tell you what the threaded rods are the most common in this scenario. However, it depends on the situation. Sometimes you're going to have established raceway, like a cable tray or conduits. It depends on the contract and depends on what the general contractor is calling for whatever reason. So, for the data, free air run is the most most common. Okay. Now, with the free air, I may have explained that to you, or I may have not. But just in case anybody is watching right now, let me bring up another scenario here. It might be a repeat, but can't say that enough. All right, let's say again, here's the floor. Here are the ceiling tiles. Here is the true ceiling. The area, and of course, there is you. There we go, baseball hat, smiley face. All right, so the area here between the ceiling tiles and the true ceiling, the concrete, that is called plenum. That's called plenum. Right here. Right, I'm just going to put it out of the way a little bit. So this is this whole area here. Now, what happens is that there's a lot of things that's happening in the plenum. There's some equipment mounted that's supposed to be out of the way, but still there. A whole bunch of wiring and controls and whatnot. There's a whole world that's happening in that plenum. One of the things is when it comes to furnace and the air circulation, the idea of the air circulation in the building is that the air is going to be pushed into the room and then it's going to be removed from the room. So circulated back into the furnace and the whole circle of life kind of goes on. There are two ways of doing this. Well, first you're going to have those so-called registers, and those are going to be mounted. Those are going to be mounted somewhere in the ceiling, and these are the supply vents, and they have ducts that are connected straight to the furnace. So the air is being pushed into the room through those supply vents. Now the air has to be returned to the furnace in order to be circulated. So let's say this is the warm air it's just I think that they took a reference from the winter thing. So so the warm air is going to be pushed in from the furnace, and the cold air has to be returned. Now, sometimes you're going to have grids somewhere, maybe in the ceiling or sometimes in the walls, and you're going to see a grid just like that, to which there's another duct that is kind of going straight, and it's a closed system, so the air goes this way here. So the air is going to be circulated. So it's a closed system, no problem. Now I'm going to change the color here. Let me get some nice red one here, maybe. Something like that. All right. There's another way of returning the air to the furnace, and it's through the plenum. So what you're going to have is the other way. You're going to have, instead of a ceiling tile, you're going to have just a grid. Just a grid. If you shine a flashlight through this, you're going to see the ceiling inside. It's just a grid, not connected to anything. So somewhere in the ceiling space, there is going to be a huge cavity, and that will be the cold air return to the furnace, and that is going to have air ducts. And this is how the air gets from this room. So this is going to create a negative air pressure, so suction begins, and it's going to create enough negative pressure so the air from this room is just going to be sucked in through that grid, through the plenum, and it's going to make its way somewhere to that cavity that is there. That cavity or the cold air return, kind of a register, can serve more than one room. So the ceiling space could be open above the ceiling tiles. It could be open and it could be common to 3, 4, 5 rooms. And that huge intake vent is going to take all the air return into the furnace. So in this case, this plenum here, let me put the text here. Okay, so this one here is going to be called cold air return plenum. Now, why am I explaining? Because this is a cabling class. This is not a plumbing class or HVAC class. Well, to us, it is important for the cable installers because the cold air return plenum is common to more than one room. So if there is fire, again, if there is a fire, anything that is plastic, anything that burns, could, through the common plenum, could make its way, toxic fumes, especially with the smoke, can enter other rooms. So that phenomenon is there's an attempt to minimize that, to make it as least as possible. So the wiring that is inside the ceiling, the wiring has jacketing. The jacketing is plastic, PVC, plastic burns, and it can produce toxic fumes. And the toxic fumes are bad for us. So if there is a cold air return plenum, then the wiring that we are supposed to use is something that is called, and I put it in the pink color, FT6. That has something to do with the cold air return plenum. All right. Now, change colors. Wiring with the jacket thing that is rated FT4 is associated with the regular plenum that is not cold air return plenum, which is enclosed HVAC system. All right. FT6 and FT4 cabling, as far as the electrical specifications and anything that has to do with the data transfer and the signal and bandwidth and whatnot, there's no difference. There could be Cat 5E or Cat 6 or whatever, Cat 7. And if it's FT6 or FT4, it is still, as far as the data transfer specifications, no different. The only difference is the jacketing that is being used, and FT4 burns quicker, releasing toxic fumes. FT6, it takes a lot more to get this thing to burn. So it's so-called fire rated. This is not a fire rated. So cold air return plenum, if it's a cold air return, and if you see those grids, shine a flashlight, you see the true ceiling, that is cold air return plenum. And if you see some of the vents that are intake vents, and sometimes they're in the walls, and sometimes they're in the ceiling as well. It's an enclosed system, then you can use FT4 cable, which is non-fire rated. If you have cold air return plenum, and if it's an enclosed raceway, such as EMT, electrical metallic tubing, which is the basically conduit, metal conduit, it's an enclosed system, then you can use FT4. But you cannot use FT4 in a free air run, so-called free air, which is not enclosed, in a cold air return plenum. And the inspectors are really, really, really specific with that. When the inspector comes to receive the building, before giving it to public use, they are going to notice that thing in half a second if you pull the wrong type of wire. Of course, FT4 cable is less expensive than FT6. FT6 is generally about 3 times as much as FT4 cabling. So there would be a temptation to kind of, for some people who want to kind of bypass the system, there would be a temptation to use the cheaper wire. Don't. All right? You're going to get caught, and it's going to cost you money, if not some sort of legal repercussions as well. All right, how do we mount things? Fixings. We have something that's called threaded rods. I'm giving you some examples here. This is what threaded rod looks like. And threaded rods can be used for many different applications, mostly for holding structures in the ceiling. You mount this threaded rod in the ceiling, and to that threaded rod you can cut it to length, and because it has a thread all the way through, so you can cut it to length, and you can mount other structures. Well, sky is the limit as far as the imagination of what you can do with that. Mostly the things are being used for air ducts, or for, in our case, to mount the cabling structure. All right, so threaded rod, relatively long rod that is threaded on both ends. The thread might extend along the complete length of the rod. So some of the threaded rods come in just both ends threaded. That gives you some limitation on the length that you can use. What you want to get is the ones that are threaded all the way through, so you can cut them to any length that you want, and you can use them as you have to. So this, I call it, this is the Lego blocks for adults. The Lego for children, you're making toys, and this is just the next level of Lego for adults, that you're making real things that are being used in construction and whatnot. All right, now the other thing I want to show you is something that's called a strut channel. It looks like this, and it comes in like 10-foot lengths or 8-foot lengths sometimes. There are different types of strut channels, but this is just a solid channel, a strut. That's what makes it a strut here. And some of them is the punched channel, half-slotted channel, slotted channel. That half-slotted is probably the most common one that you can get. It is constructed in such a swift way that you can mount things to it. Like, for example, this here that is called a spring nut. A spring nut, once you download this thing, click on this, you're going to see like a 1 minute and a half video or something like that on how to install those spring nuts. Basically, there is a female thread on the kind of like a nut here, where rectangularly shaped, that once you insert that into the strut channel, it stays there, and the spring just pushes it against the bottom rails here, so it stays in place. And if you align that with those slots, then you can just screw in a threaded rod that can go past that. You can go, so it's basically, you know, a quite universal thing, and you can put as many as you want on that. So you can use that to mount the strut to the ceiling, or you can use that to mount other threaded rods and other construction to the strut channel. So strut channel is a standardized form structural system used in the construction and electrical industries for light structural support, often for supporting wiring, plumbing, or mechanical components such as air conditioning or ventilation systems. You can cut that to length. The only thing I'm going to bring your attention to, mostly the strut is made out of galvanized steel. Galvanization is a chemical treatment of the steel. It's a coating, so it doesn't rust or doesn't oxidize. When cutting those, quite often you're going to use hacksaw, but some people use like a chop saw or miter saw, similar thing, with like a stone blade attached to it. That stone blade, with the speed that it is going to create sparks when cutting those. When sparks, that's of course because that's heat. If you heat enough the galvanized steel to the point that the sparks are coming out, then there's going to be smoke coming out of there, and that smoke is going to contain some very, very toxic fumes. I don't know exactly what's in them, but I was told that we should not be breathing those. Right? And it's something, some of those toxic fumes, they don't kill you right away. They just work in you through the years. So make sure that you use the appropriate PPE, like a proper mask, while you're cutting that galvanized steel, and don't cut it try not to cut it inside the building when there's no airflow through it. And quite often in some of the construction building, there is no airflow because the ventilation system is not installed yet. It's that building is under construction. So try to have it in some sort of ventilated area or outside or close to outside, so the fumes are minimized. Now, putting things together. So here would be there would be some sort of a mount here, and we're going to talk about what possibly we could use to mount those. And there will be threaded rods right here. Okay? And over here, what do we have? We have J-hook, 3. Those J-hooks you can mount together, you can cascade them together, so you can have them putting on the one side, hanging off of each other, or you can have them double-sided. Whichever way you want to construct them, that's fine. The possibilities are there. And those you can use to hold the wires. They're called J-hooks because they look like J. And that's what it looks like in reality. Here's a threaded rod mounted to the red iron. Well, the red iron is painted white. And there are different types of mounts. You can have the mounts that are mounted onto the steel structure. And here's a threaded rod that extends whichever length it needs to extend, and those J-hooks are being mounted to each other. Now, J-hooks come in different sizes, and those sizes are rated for handling so many wires. It's rated for so many wires of Cat5e. It's rated to handle so many wires of Cat6, and so on. It's going to have the rating on the J-hook. So sometimes you can get bigger ones like 4-inch, 3-inch, 2-inch, and 1-inch. Of course, the price changes accordingly. You would say, okay, a couple bucks difference or whatnot. Well, if you have to buy 600 of them, couple bucks on each makes a difference. So those J-hooks can be hung on the threaded rods, like I'm making a J-hook tree, for example, or they can be mounted to the side walls, or they could be mounted to the ceiling as well, straight to the ceiling. And those J-hooks come in steel, or they come in plastic, and they're also rated. So whichever you can get a better deal, doesn't matter, plastic or steel. One thing I'm going to tell you, though, those J-hooks are supposed to be suspended no further than 4 feet apart. That's the kind of common distance between the J-hooks. If you suspend them further than 4 feet apart, then the wires have tendencies to sag too much. And when the wires are sagging in the bundle, there's a pressure onto the wires, physical downward pressure against the J-hook right at the contact of the J-hook. Okay. And as we know, we're not supposed to physically put any physical stress or strain on the data wires, because that's just like stepping on them or creating micro bands. Sorry. I'm using terminology. Yeah, I'm not going to put any new here. If there's a wire that you need to run around the corner, this over here is called a macro band. Now, if you have a wire and somebody drops a steel rod on it, and that steel rod, or put some furniture on top, or whatever, something pinches, you're going to have something like this at that point right there, where something is pinching it. This is called a microband. Microband. Okay. So you want to avoid them. So this could create a bunch of microbands. Microbands are bad. They change the specifications of the cable to the point that the cable might not be certifiable as Cat6, Cat6A, Cat6E, Cat7, or whatnot. So 4 feet apart, and quite often that thing is actually mentioned in the contract, that the J-hooks should be no further than 4 feet apart. All right. Now, how do we hang those threaded rods? Well, here is a threaded rod hanger. What a coincidence. Well, the threaded rod hanger looks like this. That's one way of doing that. You drive that into the concrete ceiling, and you can hang the threaded rod from that. It has a female thread there that you can, it's same as the threaded rod. There you go. Here's your construction. Then you can cut the threaded rod to length to whatever you need, and there you go. Voila, as they say. Now, the challenge with that is that sometimes there's a perforated steel that is covering the true ceiling. Can I zoom that in? See, here's a steel layer. Now that is something that I don't want to use the word because let's be civilized, but it is not a very comfortable situation that prolongs the installation big time, because you need to drill through that steel first using a steel drill bit. Then the steel drill bit is going to hit that concrete and it's going to get dull after few uses, less than few, or less than more, few uses. So they're going to go through a lot of drill bits to drill through the steel. And then after you drill through that, and it's not easy to drill a hole in that steel because that steel is hard. Then you can go to change the drill bit, and with a hammer drill, you drive the drill bit into the concrete, and then you can drive whatever device you need. That's why survey is important, because survey is basically going to the side and seeing what is what and what is going to take to complete the job. So that should be noticed. The other thing is the ceiling quite often is covered with MMF, triple MF, man-made mineral fiber. It looks like some sort of like a dried out paper pulp mixed with sewage spread over the ceiling. That MMF is just as bad as asbestos. It's got microfibers. You breathe that, they stay in you. And they work within you. So if you see that kind of spray over the ceiling, then you have to go and mess with that to clear that out of the way. And then the particles get airborne, you breathe them. So if there's an MMF, then you need to have a proper PPE. And sometimes you have to follow certain procedures, like maybe spraying some water on it so the particles don't get airborne and things like that. There's another type of insulation that is just as good, but, well, it's newer, that is not MMF. And it looks exactly the same. You can't tell until you take it to the lab and the lab establishes this is MMF, this is not. Now, on the construction, the general contractor should have those tests. They will know that. It's their standard procedure. They will have documentation on the ceiling. They will know whether this is MMF or not. Ask them. If it's not a construction site, if it's just a site that you're just doing something like adding some more wires, and you see that, talk to the building facilities. Custodial staff is a good place to start. They will have the documentation on that. So whether it's an MMF or not. If you don't know if it is, just don't do the job. Plain simple. Just walk away from it. It's not worth it. Trust me. Even if you get fired from the job, your life is, how much is your life worth? All right. Threaded rods, mounts. What else can we use to mount threaded rods? By the way, here is, when you download this presentation, here is a nice little video showing, this is actually excellent, showing different types of fixings. So that's going to give you some little bit more insight on things like this. How are we doing with time? Yeah, we're doing good. So this is something that's called a drop-in anchor. You drill appropriate hole in there, you drive that in by hammer, and there's certain attachments to drive that in with a hammer, or there are, if you have to have a lot of them done, then of course you're going to either buy or rent a heavier drill. That takes a lot quicker and a lot easier to drill these type of holes in the concrete. Yes, you can drill that with the regular Makita or DeWalt or Milwaukee drill, but it's going to take you longer. And if you have to drill like 500 of those holes, you're going to be starting to look at some better ways of doing it, and renting or buying a heavy drill, like a Hilti gun or something like that. Then it takes a lot quicker to drill those holes and they go much easier. And then to some of those drills, you have special attachments for those drop-in anchors. So you drill that hole and then you flip it quickly and then put that thing onto the end of the drill and drive that in. So it takes maybe a second and a half to drive that in, as opposed to hammering that for 20 seconds. And if you have a lot of them to do, then it makes a difference. These are called drop-in anchors. Well, I can talk to you about this thing for 2 weeks straight and still not going to give you a good picture unless you actually go and do it. So, but watch some of those videos, like for example, this one here and this one. It's going to give you a better picture. They are being used. They are being used, those drop-in anchors. Other thing is chemical bonds. This is probably the strongest anchor, the chemical bond anchor. That also is part of this video. It's showing how that thing works. But basically what it is, you just put a lot of that chemical goo in that hole, and then you put whatever, just ball, knot, threaded rod, and quite often it's going to take maybe 24 hours or 48 hours to dry or to set properly. Some of them are quicker or not, but that is probably the strongest that I have seen. However, those when you look at this, the specs on the drop-in anchors or other ones, it's surprisingly strong, providing that the structure can handle the weight. Okay, so the anchor could be the strongest in the world, but if it's inserted in a structure that is weak, then what good is that, you know? So those chemical bonds, yes, they are. That's what it looks like from the side in a cinder block, and that's what it looks like. So, but there are different kinds. Right? Other things, equipment racks. Server or equipment racks. Standard 19-inch rack is a standardized frame or enclosure. Well, where do you see them? We see them every day when you come to school. Let's go to like room B1007 or B1009. You have those rails that make up equipment rack. Those rails are holding the equipment and being held by the equipment in place. So it's kind of like catch-22, sort of, in a good way. But those rails, mounting rails, can be mounted into the racks, and there are different racks. There are floor-mounted racks, portable, like this one is on wheels. There are wall mount racks, there are ceiling mount racks, there are just desktop sitting racks, different sizes and shapes. Some of them look like big closets, but the thing is that it's standard 19-inch rack. Standardized frame enclosure for mounting multiple electronic equipment modules. Each module has a front panel that is 19 inches wide. The 19-inch dimension includes the edge or the ears. We'll talk to you what the ears are, like rack ears, that protrude from each side of the equipment, allowing the module to be fastened to the rack frame with screws or bolts. Common uses include computer servers, telecommunications equipment, networking hardware, audio-visual production gear, and scientific equipment. That is a wall-mounted rack. Here's a floor-mount rack, okay? And they do have something called U's. One U is one unit, one rack unit. So, for example, this here, PDU, Power Distribution Unit, is one U. It takes three holes. It takes one rack space. So it's one unit. And some of those units are basically like marked here. So this one is 1, 2, 3, 4, 5, 6 U wall-mounted rack. Okay. Now, as far as that here, 19 inches goes from that end to that end. And the holes are specified, so it's a standard thing. So if there's audio equipment or anything like that, and it's rack mountable, it is to that standard 19-inch rack. Okay. Now, when it comes to those rails, the rails can be loaded or unloaded. The loaded one would be that there's a thread there already. Problem with that, if the thread goes bad, if the thread is ripped, that hole is useless. Okay? Some of them are unloaded and they use clips. So there'll be like a square cavities there. Like for example here, here's an unloaded, here's loaded. Here's the thread already in, and these here, they are supposed to take those clips. That's probably the best way. The problem is that sometimes you lose those clips. You have clips in the bag somewhere, put them away so you can find them, and then you forget where you put them. And then there's some so-called rack screws. Okay, so and then there will be the cushion washers and so on. Rack ears. Before I let you go, what are rack ears? If you have an audio amplifier, for example, here's an audio amplifier, and let's say this is the side of it here. And over here you have the volume controls, indicators, or whatnot. So here's an audio amplifier. It can be desktop mounted, so you can put it on some kind of countertop or something like that. Yes, fine. But also, if you notice, there are going to be maybe like 3 kind of holes with screws in them. You take those screws out, and quite often the rack ears something like that. This will be a rack ear that once you mount this on the side, then there will be some like according holes here in the side, and over here would be maybe 1 cavity or 2 cavities, depending to align with those rails, those holes in the rails, those mounting holes in the rails. So you put that, install that, and all of a sudden you have a rack mountable amplifier. So these are called rack ears because they look like, ears. So sometimes the professional equipment will come with those rack ears, but not attached. They're just going to come in the box, so you can attach them or not. All right. Okay, so that's. I'm going to leave that thing open-ended with a bunch of screws, loose screws, basically thrown in, because this topic never ends. So that's this. This is my way of symbolizing that this topic never ends. Just throw this thing and just keep taking it, keep studying, learning, gaining the experience as you go along, whichever direction you will go. Sometimes you will have to do with more with the security alarms. Sometimes you're going to have more experience with doing audio equipment, pro audio. Sometimes you're just going to concentrate on data. Depends on what the life takes you, where the life takes you, if you get the job in this field. Right? And that's it for the for all the lectures for this semester here. Now, you as a group, you're going to get the first part again. So you're going to see me again this week. Right? But this wraps up as far as the second part of this week. This wraps up the lecture intake of this course. So, hey, goodbyes. Yeah, okay. Well, goodbye. I'll see you when I see you.